Now let's solve the solution to exercise 14 together. The question says, if alpha and beta are acute angles such that sine alpha is equal to 3/5 and tan beta is equal to 5/12, we should find without using tables the following. We have 7 questions here. We have sine alpha plus beta, cos alpha minus beta, tan alpha plus beta, and that means all those ones, all the first 3 will be using the sum and difference identities. Question 4, 5, and 6, and which is sine 2 alpha cos 3 alpha tan 2 beta cos 3 beta, we'll be using expressions of double angles formula and triple angles identities. So now the first thing to do now, given sine alpha, let us evaluate cos alpha as well as tan alpha. Similarly, when we're given tan beta, we have to evaluate cos beta as well as sine beta. So let's proceed on, draw the diagram of representing sine alpha and also tan beta. So let's begin. We draw the diagram representing sine alpha. Is a right angle triangle with angle alpha, and also we have a right angle triangle with angle beta. Now we're given in the question that sine alpha is equals to 3/5 and tan beta is equals to 5/12. Tan alpha 3/5, tan beta 5/12. So in this case, what is our alpha, what is our opposite, and what is our hypotenuse, as well as what is our adjacent? So with that, we understand from SOHCAHTOA that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Therefore, our 3 will be our opposite and our 5 will be our hypotenuse. And in the case of tan, this will be opposite divided by adjacent. Therefore, we are saying that if this is sine angle alpha, the opposite is 3 and the hypotenuse is 5. If this is angle beta, the opposite is 5 and the adjacent is 12. So in this case, we are looking for the adjacent, and here we are looking for the hypotenuse. So let's begin with the adjacent. According to Pythagoras theorem, that hypotenuse squared is equals to the opposite squared plus adjacent squared. Therefore, we can proceed on and evaluate the adjacent here. The hypotenuse in this case is 5. That means we have 5 squared is equals to 3 squared plus the adjacent squared. So we can evaluate our adjacent, or we just say 25 is equals to, let's simplify, make it easier. Therefore, we are saying that our adjacent is equals to 5 squared minus 3 squared, which is 25 minus 9, which is equals to 16. And if adjacent is squared is equals to 16, then adjacent is the positive root of 16. So we are saying the adjacent is equals to 4. Similarly, in this case, we are looking for the hypotenuse. We have the opposite and the adjacent. So we are saying that the adjacent, the hypotenuse rather, is equals to the opposite, which is 5 squared, and the adjacent, which is 12 squared. Simplifying further, this will give us 25 plus 144. This is going to give us 169. This is hypotenuse squared. Therefore, we are saying hypotenuse will be the positive root of 169, which means our hypotenuse is equals to 13. Now we have the adjacent to be equals to 4. We have the hypotenuse to be equals to 13. Now for ease, let's duplicate these 2 triangles and move it to the next page. Now we have hypotenuse to be equals to 3, equals to 13 in this case, and we have our adjacent to be equals to 4. So with that done, we can now evaluate the various expressions of sine alpha, cos alpha, and tan alpha. Similarly, we can evaluate the expression of sine beta, cos beta, and tan beta. Now, sine alpha in this case is 3 over 5, which is opposite of hypotenuse. Cos alpha is adjacent of hypotenuse, that's 4 over 5. Tan alpha is opposite of adjacent, 3 over 4. Sine beta, opposite of hypotenuse, which is 5 over 13. Cos beta, adjacent of hypotenuse, which is 12 over 13. Tan beta, which is opposite of hypotenuse, although opposite is the opposite of adjacent, which is 5 over 12. Now we have these expressions. Now we can move to the question proper. Let's move to the question proper. The first question says we should simplify a sine a plus b sine a plus b. Now we are going to be using the expression of sine a plus b is equal to sine a cos b plus cos a sine b. So number 1, which is an expression of sine a plus b, sine alpha now, plus beta. So simplifying this according to the law, we have sine alpha plus beta to give us sine alpha multiplied by cos beta plus cos alpha multiplied by sine beta. Now, what is our sine alpha? Sine alpha is 3 over 5. Cos beta is 12 over 13. Cos alpha 4 over 5. Sine beta 5 over 13. So if you simplify this together, we will have 36 divided by 65, and we will have 20 divided by 65. Taking the LCM of both sides and simplifying it together, we will have that sine alpha plus beta is equals to 56 divided by 65. Move on to the next question, question 2. We are asked to simplify cos alpha minus beta. So cos alpha minus beta will be using this expression that cos alpha cos a minus b is equals to cos a cos b plus sine a sine b, because positive goes with negative here and the negative expression goes with the positive. So we have cos a plus b, cos a minus b to be equals to cos a cos b plus sine a sine b. So we use that expression now in terms of alpha. So we are saying cos alpha minus beta will be equals to cos alpha cos beta plus sine alpha sine beta. Now let's go back to our diagram to evaluate cos alpha cos beta. So we can see cos alpha is 4 over 5 and cos beta is 12 over 13. Cos alpha 4 over 5, cos beta 12 over 13. Similarly, we have sine alpha and sine beta. So we have 3 over 5 and 5 over 13 plus 3 over 5 multiplied by 5 over 13. So when we simplify this further, we will have 48 divided by 65 plus 15 divided by 65. Evaluating using LCM, we'll have the final results to give us 63 divided by 65, which is the value for cos alpha minus beta. Yes, we are making progress. Let's move on to the next question, question C. Now the third question asks us to simplify tan alpha plus beta. Now tan alpha plus beta will be using the expression of tan A plus B, such that tan A plus B is equals to tan A plus tan B divided by 1 minus tan A tan B. So writing that expression now in terms of alpha and beta. So we have that tan alpha plus beta is equals to tan alpha plus tan beta divided by 1 minus tan alpha multiplied by tan beta. So let's look for what is tan alpha and what is tan beta. Tan alpha is 3 over 4 and tan beta is 5 over 12. So let's apply that. Tan alpha 3 over 4, tan beta 5 over 12 divided by 1 minus tan alpha tan beta, that's 1 minus 3 over 4 multiplied by 5 over 12. So let's find the LCM for denominator. The LCM for denominator will be 12, and we will have this to be 9 plus 5, and the denominator will be expressed as 1 minus 15 over 48. So simplifying for that denominator now, we will have this to give us 14, okay, over 12, and we'll have the denominator give us in LCM term 48 minus 15. Therefore, we have this to be equals to 14 divided by 12 is being divided by 33 over 48, which is equals to 14 over 12 multiplied by 48 over 33. And we will have the final answer to be 56 divided by 33. And this is tan alpha plus beta. Let's proceed on to the next question, question D. Next question asks us to simplify sine 2 alpha. And sine 2 alpha in terms of sine 2a is 2 sine a cos a. So let's simplify that in terms of alpha. So we have sine 2 alpha to be equals to 2 sine alpha cos alpha. So what is sine alpha? What is cos alpha? Sine alpha is 3 over 5. Cos alpha is 4 over 5. So we have 2 multiplied by 3 over 5 multiplied by 4 over 5. So simplifying this, we will have 24 divided by 25, which is an expression for sine 2 alpha. Let's proceed further and move to the fifth question. That's question number 5. We're asked to simplify cos 3 alpha. Now, cos 3 alpha will be an expression that involves the triple angle formula. So we have it for cos 3a. So cos 3a is equals to 4 cos cube a minus 3 cos a. So now let's write that expression now in terms of alpha. So we will have that cos 3 alpha is equals to 4 cos cube alpha minus 3 cos alpha. Now this is similar to writing cos alpha raised to the power of 3 minus 3 cos alpha. So question, what is cos alpha? According to the diagram, we see that cos alpha is equals to 4 over 5. So this is 4 multiplied by 4 over 5 raised to the power of 3 minus 3 multiplied by 4 over 5. So this will be 4 raised to the power of 3 is 64, 5 raised to the power of 3 is 125, minus 12 over 5. So simplifying further, we have 256 divided by 125 minus 12 over 5. Using the LCM of 125, we will have this resulted into minus 44 divided by 125. And this is an expression for cos 3 alpha. So 2 more questions to go. Let's proceed. Now we want to simplify the 6th question, which says we should simplify tan 2 beta. Tan 2 beta, in this case, we're going to apply tan 2 alpha. And tan 2a is equals to 2 tan a minus divided by 1 minus tan square a. So let us write that expression now in terms of alpha. So we have tan 2 beta, in terms of beta rather, is equals to 2 tan beta divided by 1 minus tan squared beta. So the question is, what is tan beta? So therefore, we can see here that tan beta is equals to 5 over 12. So let's make our substitution of tan beta to be equals to 5 over 12. So we have 2 multiplied by 5 over 12 divided by 1 minus 5 over 12 squared. So simplifying further, this will result into 10 divided by 12 divided by 1 minus 25, because 5 squared is 25. 12 squared is 144. Simplifying the numerator, we have this to give us 5 over 6 divided by, taking the LCM of the denominator, 144, and simplifying it further, we have it to have 119. So with this, we have 5 over 6 multiplied by 144 divided by 119, and we will have tan 2 beta to result into 120 divided by 119. Okay, let's proceed further to the final question, question G. Question G is a question that involves triple angle formula because it's cos 3 beta. So we are going to apply cos 3 beta. This. So cos 3a is 4 cos 3 for cos 3a, okay, according to this, is 4 cos raised to the power of 3 a minus 3 cos a. Now this time around we are going to write, okay, we have evaluated cos 3 alpha, but now let's evaluate cos 3 beta. Let's write the expression in terms of beta. So that means we'll have 4 cos 3 beta minus 3 cos beta. Now the question is, what is our cos beta? According to the diagram, cos beta is equals to 12 over 13. So making our substitution, this will result into 4 multiplied by 12 over 13 raised to power 3 minus 3 multiplied by 12 over 13. So let's simplify further. Let's rewrite this. 12 over 13. So simplifying further, this will result into 4. 12 raised to the power of 3 is 1728. And 13 raised to the power of 3 is 2197. And this will result into 36 divided by 13. So simplifying this expression now using the multiplication sign, we have this to result into 6912 divided by 2197 minus 36 divided by 13. So we will simplify, maybe using our calculator or with LCM as the case may be. We have that cos 3 beta is equals to 828 divided by 2197. So we can see the beauty. We evaluated all forms of questions using the sum and difference identity. We use the double angle identities and also the triple angle identities.